This is Saxon Algebra 2. We're on lesson 21, page 101. Don't forget to subscribe, smash the like button, and turn on notifications. And leave a gracious comment. All right, scientific notation. What do you know about scientific notation? Y'all are in chemistry. What do you know about it? I hope there's not a big old hole in the back of my hand. It's okay if it is. Be gracious. Okay. I just thought about that, y'all. That was random, I know. But, oh well, I thought it. Okay. What do you know about scientific notation? What's proper scientific notation?
One number before the decimal.
One number to the left of the decimal, right? Times 10 to some exponent. All right. But what if I have a number that looks like this?
It's going to be a negative exponent.
Okay. I count how many times I have to move the decimal place. 1, 2, 3, 4. And is it going to be a positive or a negative?
Negative.
Negative, because when I move it back on the number line, that's negative. That's why it's negative, because when I move it back, it's negative. So it becomes 6.5 times 10, and I add negative 4 and 2, which is negative 2. All right, now, what if I had, this, and I want it in proper scientific notation, then I have to move the decimal. Here I move the decimal. Right is negative. So right is negative. Right is
Negative.
No! Right is negative. When you move it right, it's a negative number. Because we have to move it back on the number line towards the negative area. Got it? Now this time I'm moving it left. 1, 2, 3, 4, 5. Left is positive. Yes.
Your arrow is on the wrong direction.
Right, yes. I know. But I was saying when I move it back. Yeah. So right is negative. Left is positive. Right is
Negative.
left is.
Positive.
Come on, some of y'all are going to get this wrong. Because right is negative. Left is positive. Got it? Because of the idea where I have to move it back to on the number line. All right, so I said 5, so it's going to be positive 5 because I'm moving left. So I'm going to write 5.23 times 10 to the 5 minus 1, which is 4. So we're going to have rational expressions that we want to simplify. They're initially not going to be in proper scientific form. But after we get them in scientific form, the right scientific form, then we're going to multiply. And this will be a no calculator part of the test as well. All right, so look at the one and only example that we have. Right, negative, left, positive. Right, negative, left, positive. Right, negative, left, positive. That's the same way with graph transformations, y'all. When we move to the, I gotta get this correct. When we move to the right, it's negative in an equation. And when we move it to the left, it's positive. This is the same like transformations in an equation. All right. So we're going to simplify. First, we're going to write each term in proper scientific form. All right. I'm moving this one 1, 2, 3, 4 to the right. Right is negative. Okay. So it's 1, 2, 3, 4. So that's negative 4. So that's going to be 3.0 times 10. I'm going to add them to the negative 20. For 4,000, I have to move it 3 to the left, and left is
Positive.
positive. Got it? All right, for the bottom one, I have to move 1, 2, 3 to the right, and right is,
Negative.
so it's negative 3. So it's 15 minus 3, which is 12. And for 2,000, I have to move it to the left, and left is positive 3. So that's 3 plus 4 is 7. All right, so once I have it in proper scientific form, everybody look. This is the same thing as 3 times 10 to the negative 20 times 4 to the negative, times 4 times 10 cubed. Yes. Which one?
10 to the negative 16.
This one? For which one?
16.
For this one? This one.
First, the top one.
16?
No, the top is 6. Like the very first.
Oh,
Yeah,
this one is
exactly.
6?
Instead of 6.
Okay, doesn't matter. We're going to leave it, okay? Thank you. I wrote it, the problem down wrong. This was 6, but I made it 16. We don't care. Okay. All right. The numerator. 3 times 10 to the negative 20 times 4 times 10 cubed. Right? Does it matter if I say 3 times 4 times 10 to the negative 20 times 10 cubed? It doesn't matter, so I can separate them. That's what I'm going to do. I'm going to do 3 times 4 times 10 to the negative 20 times 10 cubed.
And the exponent rules tells us that we can simplify that top 10 to 10 to this.
Because then we're going to use exponent rules here. That is correct. Now, what do you think I'm going to do to the denominator? Can I do 6 times 2 times 10 to the 12th times 10 to the 7th? Yes. So I'm going to do 6 times 2 times 10 to the 12th times 10 to the 7th. So that I can use my rules of exponents. Well, what does this become?
Those both to add up to 20 to 12.
12
which
over
is 12.
12, which is
1.
1.0. All right, let's do our numerator and denominator. Multiplication is addition. So in the numerator, it's 10 to the
Negative 17.
negative 17 over 10 to the 19th. Because multiplication is addition. Now, division is subtraction. So it's negative 17. It's negative 17. Division is what? Division is, yes, thank you, Ben. Negative 17 minus 19, which is what? 10 to the negative, no, negative 17 minus 19. Well, it's a big number. It's a big negative. 36. Final answer. Okay, I have a question. What if what if we ended up with, okay, what if we ended up here? This would be what? 240 divided by 12, which is what? What's 240 divided by 12? 20. Would I leave it like that?
No.
I would not. I would write it in proper scientific form. So I'm going to move the decimal 1 to the left, which is, left is
Positive.
positive. So it's 2.0 times 10, I add 1. Now, what if it would have been this? Then that's 3 divided by 12, which is
0.025.
1/4, which is 0.25 times 10 to the negative 36. Would I leave it like this?
No, ma'am. You would move the decimal place 1 right,
Which is,
which would make it 2.5 times 10 to the negative 37.
correct. All right, so you're always going to leave your final solution in proper scientific form. Got it? All right, the other part of this lesson deals with statements of equality, and it deals with ratios. But for this one, we're going to write equations. And remember, we always write as we read. And we just establish our variables, whatever variables we want them to be, typically X and Y. So looking at example 2 on page 102, it says the ratio of two numbers is 3 to 4. So I could write X to Y, that's the ratio of two numbers we don't know, equals 3/4. So somehow they've reduced this to 3/4. We don't know what the numbers are. I cannot use a ratio table for these because the operations for both of the problems are not the same. This is a fraction equals a fraction, and the second part says their sum is 84. This is adding them. So when you have two separate operations, addition, division, you cannot build a ratio table. However, how would you think you would solve for this? Substitution. So which one would you solve for a variable and then substitute in the other one? So which one would you solve for the variable?
I'd like to solve for X first.
Okay, in which equation? The first one or the second? Locke, hang with us. First one or the second one?
Me?
Yeah.
I think I would substitute X in.
Which one would you solve for X in? The first one or the second one?
Second one.
The second one. Always use the one that has addition or subtraction. So we can subtract Y on both sides. When we subtract Y, we have X is 84 minus Y. That's what I'm going to substitute in for X in the first equation. All right, so then we have 84 minus Y over Y is 3 over 4. I only have one variable in the equation. Now I can solve. And I do so by cross multiplying. So that's 3y. When I cross multiply this way, it's 4 times the entire value of the numerator. Got it? I have to multiply 4 times both terms. So I end up with 3y equals, what is that? 16, 30, is that 336? 84 times 4 is 336. Minus 4y. I'm going to add 4y to both sides. And I end up with 7y equals 336. Then I divide both sides by 7. What's y? 48. Well, once I know y, then I can solve for x. Because x is going to be 84 minus the value of y. And what is that? 36. So x equals 36. That's what they did. They took 36 over 48 and simplified it by dividing by 12 each term. Does that make sense? All right, look at example 3, the final example for this lesson. The sum of two numbers is 128. What am I going to write? The sum of two numbers is 128. And their difference is 44. What am I going to write? Okay. Always when this is the case, I'm always going to use elimination. Because the variable y is going to eliminate. When we do one equation is the sum, the other equation is the difference. So we end up with 2x is 172, is that right? And then when we divide both sides by 2, x is 80. Is it 86? Is it 86?
Yes.
Okay, good. So I can find the value of y. What plus 86 gives me 128? What's 128 minus 86? Oh, that's not too hard. Is it 42? Add them. There we go. 42. Is there a difference 44? Yes.